segment lengths. We've been doing angles. Now we're going to take a look at lengths. In this first section, we're looking at two chords, like chord AB and chord CD, where they intersect inside the circle at E. They're not intersecting at the center. They're not bisected, but each chord is cut into two pieces. On the first chord that went from A to B, this E is cutting it into two parts. So we've got EA and we've got EB. What they're telling us here is take those two chords and multiply them. The other chord that went from D to C, it's got E in the middle, so I can go from E to C and I can go from E to D for the two parts. We multiply those together and those two products equal each other. So on example A, this chord is cut into two parts, X and 6. Multiply those together. Oops. It's like 6 times X equals. Now on the other chord, go to the two parts, 3 and 4. Multiply them together. So in total, I have 6X equals 12. So X has to be 2. Part B, same thing. So on this one diagonal, I've got an X and a 12. Multiply them together, that's 12X. The other diagonal has a 6 and an X plus 4. I'll have to group X plus 4 together with parentheses. And so then to multiply those, I'll have to distribute. I'll subtract 6X from both sides. And I see that X is equal to 4. That's what we do if we have two chords. For the rest of this sheet, we're dealing with either two secants or a secant and a tangent. So we'll do things a little bit differently with secants. So you see on this secant here, the one that goes from E to B, there is this external part. It wasn't red, now I just colored it in. But that external part, EA, is what we're going to start with here. I'm going to try and write external here right above it. What you're going to do is take that external part, the EA, and you're going to multiply it by EB. Well, EB is the entire thing. So you're taking the external part times the whole thing. So I'm writing there external times whole. And then on the other secant, the external part is from E to C. So that's external. And then ED goes through the entire secant. So that's external times whole, external times whole. That's really the process we use. I want to do example B first, and then we'll come back to A. Seems like more of our examples will probably be more similar to B than A. But if we look at B, it doesn't matter which secant we use first. I'll use this top one. Its external part is 5, so I'll start with that. So that's external, and then I have to multiply that by the whole. So I need to find the length of the entire secant. So that's starting on the circle and going all the way to the outside point. Now it doesn't give me that distance, but it does break it into two parts, 3 and then 5 more. So if I want the whole thing, I just add together 3 and 5, giving me 8. So the external part was 5. I can even write this above it again, external times the whole. Then on the other secant, its external part is 4. Oops, got an extra N in there. Oh, I forgot an R, that's what happened. Okay, times the whole thing. The whole thing, notice we have an X and a 4. Remember what we did with the 3 and the 5. We added 3 and 5 together to get 8. So here I have to add these two parts together. So there's an X and there's a 4. Add those together. Because it's added, I have to put it in a set of parentheses, group it together, and then I'll have to do some distributing. So it's external times whole. Okay, so let's solve this. 5 times 8 is 40. Distribute 4x plus 16. Subtract the 16. X is 6. Now, if I go back to A, if I do the top secant, its external part was 3. And then the entire secant, this one's a little different than the last one because it doesn't tell you separately what this inside part is. Instead, it tells you that the whole length, notice that goes from start to end, the whole thing is x. So that is the whole. I can put x in as whole. I don't have to add the x with the 3 because the whole thing was x. So it's a little different. On the other secant, the external part is 4. The whole thing there I do have to add. 8 plus 4 is a total of 12. So 3x equals 48. X has to equal 16. Same idea down here. Here we have a secant again, so we have an external part, EC, times the whole thing, which is ED. So external times the whole. But then we have a tangent up here. Notice the tangent's external part is the whole thing. So when you take the external part of EA times the whole thing of EA, you have EA times EA, or as they write it here, EA squared. So in a tangent, remember, external and the whole are the same thing. They get multiplied together. So as I look at example A, the external part on the top secant is 5 times the whole thing. Well, here I have to add the two pieces together, 5 plus x. On the tangent, there's a tangent over here. The external part is 7. The whole thing is also 7, so I have 7 times 7, or just 7 squared. On the left side, I have some distributing to do. We can subtract 25. (49) minus 25 is 24. Divide that by 5. X equals 4.8. And then the next problem is by far the toughest one on here. And it goes back to something that you have to use a strategy you learned about in algebra, but I don't think we've done it at all this year. So you may not remember this very well, but it starts off the same way. On this secant, we have the external part of x. That's going to get multiplied to the whole thing, which is 10 plus x, or x plus 10. Equals, over here we have the tangent, the external part is 12, and the whole thing is 12, so that's a 12 squared. Distribute the x, you'll notice we get an x squared and an x. So I can't just square root to get rid of a square when there's also an x. So the way we solve this is by factoring, and that's what we did. You would have done a decent amount of an algebra, but I don't know how well you remember it at this point. First step in factoring is you want to set it equal to 0. You want to put everything on the same side. So I just took that 144, I wanted to get rid of it, so I just subtracted it from both sides. That's why I have a negative 144 on the left side and a 0 on the right side. And then factoring is when we're trying to turn this into two sets of parentheses. Some of you might think of this like the opposite of FOIL. But if we have an x squared on the left, x squared comes from x times x. So that's what goes first in each set of parentheses is x and x. And then we look at the end, the negative 144. We have to come up with two numbers that multiply together to make 144, but at the same time, they add together to make the 10. So you multiply them to make negative 144, add them together to get 10. So typically when people are thinking of numbers that multiply to make 144, you might think 12 and 12, but the problem with 12 and 12 is they don't add to make 10, so they don't work. So I have to think of other numbers. It just so happens to be, in this case, a negative 8 and a positive 18. They multiply together to make negative 144, add to make 10. Then you set each factor equal to 0. Solve them both, x equals 8 and x equals negative 18. Now, negative 18 doesn't make sense in this context because it's a distance, so 8 is the only one that works.